Now we're going to discuss parabola. Parabola have two types of equations, where this is the type of start with y square and this type is start with x square. So notice that this is only the factor of y square, this is only factor of x without square. So this is x square, then this is factor of y. And then for y square is a parabola shape, open to the left or to the right. So it is horizontal symmetrical axis. So symmetrical axis will be like this. So it having a horizontal symmetrical axis. So the axis is parallel to x-axis. Meanwhile, for parabola, which is the formula x squared, start with x squared, it will be open up or open down. So its symmetrical axis will be vertical symmetrical axis. And then this axis is parallel to y-axis. So now we're going to look on the first type, open to the left or open to the right, where the formula standard form will be y minus k squared equals to 4px minus h. So to know that whether this parabola is open to the left and open to the right, it depends on the value of p. So if the value of p is positive, the parabola will be open to the right. But if your p value is negative, your parabola will be open to the left. So that will be our shape for this parabola. So from here, we can read out y coordinate equals to k and then x coordinate equals to h. So for this coordinate hk, it will be our vertex. In parabola, we also will have a focal point inside the parabola here. So in this concavity inside the parabola here, we will have a focal point. So from vertex to focal point, it is a distance of p. So from vertex to the line that opposite from this parabola, it is a directrix. So same with here. So the distance between focal point and vertex will be the value of p, and the distance between this point to the line of directrix is the distance of p units. So therefore, when you want to find our focal point, where vertex is hk, so when you want to find our focal point, we are moving to the right, p unit. So moving to the right, p unit, so coordinate x, which is h, we're going to add on p unit. Meanwhile, in order to find this equation of directrix, so it is a vertical line, so the formula will be start with x equals to something. So what is the value? We can observe here, this is our vertex point. So we having a p unit to the left. So this x value will be h minus p. So to the right we add on, to the left we minus for this p unit. So for the parabola open to the left, where vertex is hk, so when you want to find this focal point, means x coordinate will going to minus p, because from vertex here, we're moving to the left for focal point. So we're going to minus p unit. Y coordinate, no changing. Meanwhile, for directrix, line directrix here, it will be equation of x equals to something. So when you having your p unit to the right, so this will be h plus p. Therefore, for this operation here, plus and minus p, I refer to the p unit. So the positive and negative is for our direction, for open to the left or for open to the right. So for this concept, when you're having p negative, I won't take the negative in calculate in this p. So I will take its units only. So the negative is just for us to know the direction. The parabola is open to the left. So another type of equation for this parabola will be in the standard form, x minus h squared equals to 4py minus k. So from here also the same thing, we observe our P. If P is positive, it will be concave upward. If P is negative, it will be concave downward. From the equation, we can read out x coordinate and y coordinate. So for this x and y coordinate, it will be referring to our vertex. So our vertex here is HK. So in parabola, we were having a focal point inside this parabola shape, and in opposite here, we were having a directrix line. So for this parabola concave downward, focal point will be inside in this concavity, and then in the opposite of this parabola, this is our directrix. In order to find out the focal point, so we notice that from vertex to focal point, it will be a distance of P. From vertex to directrix, it will be distance of P. So same here, from the vertex to directrix is a distance of P. Here also a distance of P. So in order to find out this focal point means we're going to moving up. So moving up, x coordinate will not change. So y coordinate from vertex we are going to plus P unit to find out this focal point. Meanwhile, for this directrix, you can notice that directrix is a line equation, is a horizontal line equation. So equation will be start with y equals to something. So what's the y value? We're referring to the k here. When you're moving down, means this k will go into minus p unit. So same concept will be applied for this parabola concave downward. As we know, vertex is hk. So when we want to moving down for this focal point, x coordinate will not change, y coordinate will be minus p unit. So when you want to find this directrix is a horizontal line, so it will be p unit moving up from this vertex. Therefore, look at our directrix. It will be a horizontal line, so the equation will be start with y equals to something. So when you move up p unit, this coordinate y will be going to plus p unit. So finally, in parabola, when we drawing the graph, it is important that you have the properties on drawing focal point, vertex, and its directrix. Meanwhile, in calculation, you have to very be careful with what formula that you're going to use on and what is your vertex and what is your value of P.